Okay, so here's lab problem 2. Let's go ahead and go through it. So our step 1, our H0 is mu1 equals mu2 equals mu3. I have 3 means. H1 is at least one mean differs. And if you're going off the wording, then the second one, the H1 would be your claim. Again, I'm fine if you use H0 as your claim. I'm good with either one of those. Alpha is 0.05. That's my step 2. Step 3, find the p-value, 0.00167. So then step 4, we're going to reject the null hypothesis because my p-value is less than alpha. And again, you're going to compare them. You're not drawing a picture for this one. There's no pictures for this one because you don't have a critical value. So instead, you have to write out that p-value is less than alpha, or not less than alpha, or greater than alpha, whichever one it is. Right. So in this case, p-value is less than alpha. 0.00167 is less than 0.0500. And again, if you have trouble with these decimals, make them the same number of decimal places. And yes, this is 5 decimal places, and the last one was 4, but because it's 3 sig figs, I care about how many sig figs I have. Here I have, go to your first non-zero, so this is my first one, my second one, my third one, 3 sig figs. That's what we care about. So it's all about the sig figs. Okay. So there's enough evidence to conclude that at least one mean differs. That's all you need. Questions before we move on? Okay. Everybody's all good? All right then. Let's go ahead and take a look. I put a lot of comments into this. Maybe I shouldn't have. Maybe I should just do a new one. That might be better. Okay, so like I've mentioned before, a lot of people screwed up the last exam 3 because they did the wrong problem, the wrong type of problem, like they did a hypothesis test when they should have got a confidence interval, or they treated it like a mean when it was a proportion, or vice versa. So it's really important to be able to tell these apart. If you screwed that up on the exam, then you should go back through the last lecture we had, more work PDFs and or the videos for that lecture to kind of make sure you really understand how to tell those apart. It's usually the last thing I did of that lecture typically, or the middle. Some of the times, yeah, usually it's at the end for chapter 7, 8, 9, because it's really important you know how to do that. If you don't know how to do that, then you're going to be kind of SOL for the final. And so since chapters 10, 11 are a big part of the final, we're going to go through that for these problems now. So the first one is it 2 variables, 2 different variables, right? So you can either have 1 variable or you can have 2 variables. So if it's 2 variables and we're trying to look at a correlation, and the variables don't have categories. 2 variables, no categories. So in other words, 2 variables where the answers to those variables, the answers are numbers. This is good. 2 variables, answers are numbers. As opposed to 2 variables where your answers are categories. All right, so this one down here would be 2 variables, but the answers are categories. So that's interesting because that is kind of what the crux is between those 2. So here you have 2 variables and the answers are numbers, and trying to find a relationship between them. So that would be, this is your chapter 10 stuff. And like cars and revenue, number of cars and revenues. If someone says, if you have numbers of cars as your variable, your answers are not going to be Chrysler, Plymouth, Blue, Toyota, right? They're going to be numbers. If your variable is revenue, your answers again are not going to be things like high or medium or low. These, if your answers to these are numbers, not categories, then we're looking at chapter 10. You have two variables, and the answers to those are numbers. And also, the nice thing about it is you're going to have this little t-table here with your x's and your y's, or your one variable and the other variable, and you're going to have stuff written in here of some sort. I don't know what, but you'll have, they'll go together, right? They'll be these matched pairs. The second thing that we learned about was this part here where we're taking a number. You're taking numbers in categories. So these are just tally marks, comparing observed and expecteds. So here, my variables, we can either have one list, which is one variable, right? So this is one variable. Again, answers are categories. Or we might have two variables where, again, the answers are categories. Either way, with a chi-squared, my answers are categories. They're not, I'm trying to put some wouldn't still see it. They're not numbers. So these are my chi-squareds. So this is going to be chi-squared. And it's either going to be a chi-square. This is 11.1 and 11.2. 11.1 will be the list. And this is what you do with it. You can either do this thing here to find the chi-squared, or you can just do your observed minus expected, because you're only going to have only going to have 3 or 4 of them at the most. So you can manually compute them, or you can do this whole list thing. But again, this is where you compute the expecteds, right, by hand. The observeds are given to you. If it's a matrix, then you're given the observed in a matrix form, and you only have to compute the first and last one, and then you do that stat test chi-square test to figure out what your chi-squared is. The last thing we did was 11.3, which was the ANOVA. And that's when you have multiple lists, 3 or more lists, and you want to see the means are different. So it's going to talk about means. Means are going to be in there. So you have 3 or more means, 3 or more lists. And then you just put the L1, that's the straightforward one, right? You just put L1, L2, and L3 in, and then you run stat test ANOVA. All right, so some of the cues for these ones, again, this is linear regression. Chapter 10 is linear regression. Oh, I can't write well here. This is linear regression, then regress, lin-reg. It's also, you might see the words correlation. You might see the word line, stuff like that. And then this one you're going to have observed and expected. And again, they're going to be categories. And then ANOVAs, I think, is a little bit easier spot. So let's take a look. I want you guys to take 30 seconds on your own. Let me point out some stuff, yeah. So the matrix is going to be, the observed ones, I'm just going to give you, you're going to be given a list of observeds like this, and you're going to have to find the expecteds. The matrix is going to be, we're going to have some sort of matrix where you have, observes, you have your observes in multiple rows and multiple columns, at least 2 rows, at least 2 columns, like that. And then the means are going to be something along the lines of, you're going to have, right, you're going to have some sort of title, and you're going to have, stuff in lists, which may or may not be the same length. But you're only going to have, you're only going to have categories or headers up top. And here you're going to have headers. You're also going to have headers up top, but you're only going to have one thing, not a list below it. And here you're going to have two lists, headers up top, two lists. So kind of let me show you where the headers are. So here you're going to have headers here, and here you're going to have headers here, and headers here. Here you're only going to have headers just there, and here you're only going to have just these two headers there. So that kind of makes it a little bit, you'll see what I'm talking about. So I want you guys to, that's not helpful for you. So take a minute and try to figure out, just from looking at the data that you're given, what kind of problem are each of these? Right, so it'll either be a chapter 10, linear regression, or it'll be an 11.1, a chi-squared, or it'll be a chi-squared list. Or it'll be a chi-squared. Oh, this is just awful. Squared this. Squared matrix. Let's go to that. It's better. Okay. So, what do you guys think? What's this one over here? This one on the far right? Private chat mean. Tell me what it is. Far right one over here. I'm waiting to hear private chats. Talk to me, people. Wake up. Heard from 2 people, 3 people, 4 people.
This is Ayang. When I do the private chat, I put in the answer and then I hit to everyone.
No, private chat, you pick me on the little list. You choose me, and then you just send it to me. Don't do the everyone. Everyone goes to everyone. There's a little drop down. There's a little arrow with a drop down. You pick me.
Okay, so I did it. So did you receive from me then?
Nope. Type something in and hit enter.
I said chapter 10 because it's a linear regression problem.
Okay. Well, don't tell everybody. Not everybody knows. Okay. Close enough. All right, so it's linear regression. This is chapter 10, linear regression. Because, again, you have an x. Let me go back here. Move it up a little bit. Ooh. All right, so this is chapter 10. All right, we have an x, we have a y, and these are really all just points, right? X comma y, points. They're all points. And you'll notice we only have all my data is numbers, age. Those are all numbers. Great. So then, what about this? What about this bottom one down here? What's this one? Okay, people are a little lost. Let's go with the easier one. Let's go with this top one here, the top left. We'll do that one next. That one's a little straightforward. Top left. I've heard from 3 people. Top left, this one here. What's that one? There we go. Okay, I've heard from 7 people. 8. Come on. We're waiting. Okay, so this is not a matrix, because if it was a matrix, I'd have to have categories over here also. I don't have categories there. I only have categories here. So this is lists. This is chi-square lists, because I have categories, I have categories only on the top or on the side. If you only have categories on one side, either the side or the top, then it has to be either chapter 10, where you have 2 of them, or if you have 3 or more, then it could be, this is ANOVA. $11.3. All right, so then how about the one below it? Let's take a look at the one below it. The one below. What's that one? I've heard from 3 people. Jay, try to hit to me, wherever I am, and then type a message in there.
And then what am I supposed to do?
And then what says type message here, type a message and hit enter. Or type a message and hit.
Oh, that's what. Oh, okay, I see it.
Okay, so you guys have this one. It is a chi-squared matrix. Here's my matrix. Because I have categories on the top and the side both. For a matrix is only a matrix if you have rows, so in other words, categories on the side and the top both on the top and the side. So this is a chi-squared matrix. $11.2. Okay, and then the bottom one? Heard from 1 person. 2, 3, 4, 5, 6. Okay, and a couple people got this wrong, so that's okay. All right, so this one, there are things along here, and there's stuff along here, but let's take a look and see what's along there. Is what's along here 2 different categories? Observed and expected, those 2 different categories? They're actually, they're actually the same category. It's just observed, and then you have these expecteds that go with them. They're 2 separate things. So this is my O and my E. So really, it's just, this is my list right here. So this is the chi-squared list. 11.1. Does that make sense for folks? You guys kind of on board? And remember, I'm always going to give you the observed. Here, my observed is a list, and you compute the expecteds. Over here with the chi-squared matrix, my observed is a matrix, and you only have to compute the first and last expecteds. Okay, and then, okay, good. And then these 2 don't have observed. They're just, these are them. This is it. 2 lists that are all paired up, or 3 more lists. Here, this is just, these aren't lists. The accidental, it just has a number, not a list. Because my data, what's my data on type of death? It's not numbers, it's type, it's words. Accidental, homicide, or suicide. How'd you die? Well, I died by an accident, or I died by homicide, or I died by suicide. Right? Those are the answers. My answers are not numbers. My answers are categories. Right? Words. How did you die? Okay. So now we're going to do This is it. Maybe prettier, not so much, right? So these ones don't have things on the side. That's what I was kind of pointing out. There's nothing on the side. Maybe I'll make it big black. X. Maybe I should make this bigger, right? Nothing. And even this is worse. I think I'm just going to leave them out. So you kind of realize that there's nothing on the sides. They only have stuff across the top. Okay. All right, so now we're going to take a look at what kind of problem is this. And, wow, that's terrible. Okay, let's go back to this, and we'll go down to that. So take a minute, take 30 seconds, and tell me what kind of problem this is. We have 10 of them to get through in 6 minutes. Read it, and decide from the words and from everything else what kind of problem it is. Okay, so this one is confusing for people, I think. So you can either do it off the words or you can do it off the picture. So again, if it's a chi-squared, you need to have categories across one area and then observed and expected along the other area. Do we have that or not?
No.
The other chi-squared, you'd have categories here and categories there. Are these two different? Do we have we don't have categories across the top. So once you know we don't have categories across this thing here, it can't be a matrix. This cannot be a matrix. So you might say, well, it looks kind of like a matrix, right? But there's no categories up here, so it can't be a matrix. All right, well then, that leaves me with either a ANOVA, but I need 3 or more lists, and they're not 3 or more lists. There's only 2 lists. So it kind of leaves me down to only this being my X and my Y. That's my only option here. And these are pairs. So this would be 1500, 650. Is that making sense for people now a little bit more? So maybe your first step is to say, is it a matrix? And see if there's categories across the top and the side. And if the side is observed and expected, maybe. And then if not, then you got to look at the other options. The other way you can look at it is seeing how there's this word linear correlation right there. That's the other dead giveaway. Okay, take a look at this one. Type it out quick, guys. Come on. Heard from 2 people. 3 people, but they didn't say whether it was a matrix or a list. Okay, good. So this is a matrix. Why? Because I have categories across the top, and these are 2 different these are categories, 2 different categories. Serial and non-serial, those are 2 different categories. So this is a chi-squared matrix. Also, you'll see a percent. Do you see that percent? Proportions are here, I think I have it. Proportions, those go with chi-squareds. Chi-squareds are proportions. If you're talking about means and numbers, you're looking at ANOVA, or you could also be looking at, if they're numbers, then it could be chapter 10, if your data is numbers. All right, next. Okay, looks like you guys have this one too. It's a chi-squared matrix again. You have categories across the top, and you have categories along the side. Good. Next. Heard from one person, two people. Okay, now we're getting some confusion here. Yes, interesting. Right. Okay. That's interesting. Right, so some people are saying, well, I have 0 through 9 here, and those match up with 280, 303, 331. So they're thinking that these are x's and y's, which that's interesting. The reason why it isn't is this reason here, because chapter 10 will always talk about there being a relationship or a correlation, and here we're asking if they're equally likely. So that's kind of the only way you can, that maybe one could be certain they could tell the difference. The other way, oh, and then frequencies. Ooh, that's the other way. Here's another one, thank God. The other way is there's frequencies, right? And when we're talking about frequencies, right? Frequencies equal proportions. So when you're talking about frequencies, frequencies are going to be your proportions. It's going to be this many out of that many. So this is really 280 out of however many there are. So these are frequencies. They're going to be proportions. 280 out of blank number of people. So frequencies are always going to be chi-squared, one of the chi-squareds. I got to write that down. Okay, so this is a chi-squared list, 11.1. So this is your list of observed, and then you're going to have to compute all your expecteds off of the equally likely. All right, we just have it. Let's do at least 2 more, and then I'll let you guys go. Take a look at this one. Heard from 2 people. 3. 3 people, that's it. Everybody else leave. Okay, you guys are correct. This is, well, most of you guys are correct. This is ANOVA. How do you know? Because there's 3 different things here. These are not observed and expected. There's multiple things here, and it can't be a matrix because I have nothing up here. Do you guys see what I'm saying? So I've got lists. I've got 3 or more lists. So this has got to be ANOVA, L1, L2, L3. And the other way we know is it says mean. So that's my verbal cue, is that it says mean. All right, one last one. This is not easy, huh? Some of them get a little tricky. What do you guys think? Right, there's some good guesses. There's so many guesses. Everyone's all over the place with this one. Okay, so this one you got to read it. All right, so frequencies, proportions. Let me give you guys that hint. You got proportions. So that means that it needs to be a chi-squared because you've got proportions. So, and then expected, you have expecteds, right? So here, games played, World Series games played. Is 4, 5, and 6, are those, is that my data, or are those, what's up with those? You play World Series games, and how many games did you play? You played 4, 5, or 6. So these are my categories. Those are categories. So then the other question is, are these guys categories? Actual and expected? These are actual. I won't be this tricky. But this is actually your actual is what you observed. Your expected is your, and what you expect is what you expect. That's your E. So that's actually, this is actually a chi-squared list. And these are what we actually got. These are observed. And then the expected proportion, you have to multiply that by your totals to get your actual numbers in there. Okay, so I think we'll stop here. We'll go over some more of these next class, but we're going way over time. But I think I think we need to really think about this because we need to spend some more time on this because you guys need to be able to tell these apart. And if you can't, you're just going to all bomb the final, honestly. So it's really important that you be able to tell these apart. And you know, look for proportions or frequencies. Those mean chi-squared because chi-squared kind of goes along with that binomial stuff, the categorical stuff, and the means and the chapter 10 and the ANOVA kind of go more with actual numbers. All right, have a great day. I will talk to you guys later.
Professor Young?
Yes.
So on Thursday, will you go over again chapter 10, 11
Yes.
review?
A little bit. So on Thursday, I'm going to do a little bit of chapter 10, 11. So thank God we took the test earlier, else we wouldn't have time. I'll go over a little bit more of how to tell these guys apart. And maybe we'll go through a chapter 10 one because it's been a long time. And then we also need to go over chapter 4. Chapters 1, 2, and 4 because it's been a long time since we've seen them. And then I'd also like to maybe touch on chapters 7, 8, 9 a little bit because some people struggle with that exam. I feel like exam 2 you guys got down a little bit better. So I probably won't go over exam 2.